What are the key features of fatigue fracture in fractography? Imagine a tiny crack slowly growing inside a metal part, invisible to the naked eye, until suddenly it causes a big failure. That's what happens in fatigue fractures. When materials are repeatedly stressed, tiny cracks can start and grow over time. Fractography helps us see these cracks and understand how they formed. The first thing to look for is where the crack began. Usually, fatigue cracks start at a stress concentration point like a surface scratch, a notch, or a sharp corner. These spots make it easier for cracks to form because they focus stress in one area. Next, we examine how the crack grew. It often leaves behind fine, parallel lines called fatigue striations. Each striation marks one cycle of loading, showing us how the crack slowly advanced with each stress cycle. As the crack gets bigger, the fracture surface shows different zones. The fatigue zone is smooth and shows the striations, indicating slow crack growth. When the remaining material can no longer support the load, the final fracture zone appears. This part looks rougher and more irregular, showing signs of sudden overload failure. The transition between these zones is a key feature in identifying fatigue fractures. The surface's overall look is also telling. Fatigue fractures tend to be smoother and show little plastic deformation, unlike ductile overload fractures which are rough and deformed. The crack usually propagates perpendicular to the main tensile stress, creating a roughly flat, planar fracture surface. Sometimes, multiple cracks start at different points and merge, creating curved ridges called ratchet marks. These marks reveal the crack's multiple origins and how they grew together. Environmental factors like corrosion or temperature can influence the fracture's appearance. For example, corrosion can make the crack growth faster or cause additional features. Also, the way the load is applied matters. Bending, twisting, or tension can change how the crack develops and what features are visible. And like some brittle fractures, fatigue cracks don't usually produce shear lips, which are angled edges seen in other failure types. Looking at these features under a microscope, especially with scanning electron microscopy, helps failure analysts piece together the failure story. They can identify if a crack started at a defect or was caused by repetitive stress. This information guides engineers to improve designs, select better materials, or change usage conditions to prevent future failures. Understanding fatigue fracture features is vital for keeping mechanical parts safe, whether in airplanes, medical devices, or everyday machinery.